This is 2012 question 5. Based on skimming through the problem and reading keywords, I would say that this is a slope field / separable differential equations problem, okay? So again, people tend to flip out when the variables are switched. Remember that we normally have x and y, and we normally have dy dx. So here they introduce db dt. So really, x is your t, and y is your capital B. Okay, they talk about a bird population. All right, or sorry, the weight of birds. But here we go. Part A: is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So the key phrase here is weight faster. That is a form of a rate. So basically what you guys are doing is you want to see at 40 grams and at 70 grams, is your rate faster at 40 or is it faster at 70? So basically you're plugging in 40 into B. That'll give you 1/5 times 100 minus 40. Okay? Or if you're plugging in 70, which in this case that'll give you 1/5 100 minus 70. Now you could analyze it. It's easier in this case to just kind of simplify it through. But if you look at the scoring guidelines, at 40, when the bird's weight was 40, it was gaining weight faster at this moment than it was at 70, okay? So you make a conclusion, therefore the bird is gaining weight faster when it weighs 40, okay? Don't just leave it as these two. You definitely want to make some type of conclusion there, okay? Part B. They ask you to find the second derivative. This popped up in 2011 as well. Finding the second derivative, again, I'll guide you through it. Here we go. Let me erase this here. If you have the first derivative, you want to find the second derivative. Make sure that you guys are writing the second derivative accurately, okay? So before I find it, what I want to do is I want to just simplify the first derivative. That would just be 100 over 5 minus 1/5 of b, okay? So now when I take the derivative, it's a lot more straightforward. The derivative of 100 over 5 is just 0 because it's a constant. The derivative of negative 1/5 b is just negative 1/5, but with respect to b over dt. This is where you re-plug in what you had to begin with. This is negative 1/5 times, now db over dt originally is 1/5 times 100 minus b. You see this very often. That's enough for you to leave it there as a second derivative, but let's see what they're asking now, okay? They're asking you to use that second derivative to explain why the graph of b cannot resemble this graph. So there's a reason why they're asking you to find the second derivative. Remember that when you get to that moment, you're talking about concavity, okay? So if you notice this graph here, the weight starts at 20 and it ends at 100. So if you were to plug in any number in between 20 or 100, this quantity right here will come out positive no matter what, okay? Assuming it's not 100, okay? So from 20 and anything up to but not including 100, this whole value will come out positive there. Times a 1/5 times that negative 1/5 there. So no matter what, this second derivative will have to come out negative, okay? So here's what we know. No matter what value we plug in, this second derivative will always come out negative. Now, what does that say? That we now know that b is concave down. Now go back to this question here. It says, explain why the graph of b cannot resemble the following graph. So according to our calculations here, no matter what weight we put in, the graph is supposed to be concave down. If you notice, the graph starts off as concave up, then switches to concave down. So there's no way that this second derivative, this picture cannot resemble what we're talking about here. And that's basically what they say in the scoring guidelines. Okay? Part C. Use separation of variables to find the particular solution. This is the majority of your points again, just like in 2011, just like in your FRQ packet for slope fields, all right? So here we go. We have dB over dt equals 1/5 times 100 minus b. So remember, whatever is on top stays there. Okay, in this case, dB is going to stay on the left, and all the t's are going to go to the right. So we're going to have to divide out 100 minus b to bring it to the other side. And at the same time, we're going to have to multiply by dt on both sides. So that goes away, and so that goes away. Okay, so that'll give you the second line right here. Okay, now the only tricky part is the left-hand side. This tends to throw people off. Now remember, this down here is a function inside of another function. It is not a simple linear because the coefficient is not positive 1. If you notice, if it was 1 over b minus 100, then the integral of that would just be the natural log of b minus 100 because that bottom function is simple. Now, it's not simple in the case because there's actually a negative 1 in front of that linear function. So you have to use mental use substitution. The derivative of the bottom is just negative 1. The reciprocal of negative 1 is just negative 1, which is why you have a little negative out here. So that tends to throw people off. It does pop up very often, so watch out for that. Here we just use mental use substitution. The right side, very straightforward. The integral of a constant is just something linear. Don't forget your plus c. So we separated, we integrated, now we have to find c. They do give us a condition. At b of 0 is equal to 20. So at time 0, the population is 20 here. So here we go. At time 0, the population is 20, which is what you see right here. Okay? When you plug that in, you should get this. Okay? You could leave it as equal, but that is pretty simple enough to simplify. I'll leave that up to you on what you want to do. Now, here's where I would deviate a little bit. I would go ahead and I would write my function now as the negative natural log of 100 minus b is equal to 1/5 t, and then I plug in my c, minus the natural log of 80. Okay, your only job now is to get b by itself, no matter how messy it gets. So here we go. I'm going to get rid of this negative right here by multiplying both sides by negative. So natural log of 100 minus b will now equal the negative of blah, everything on the inside, 1/5 t minus the natural log of 80. Okay, so now to get rid of the natural log, I'm going to e both sides. So now 100 minus b will equal e to the negative blah. I'm not going to write everything down, okay? So if you maneuver this around, you should get b equals 100 minus e to the blah, which is basically what they have, but just not as simplified. And that's it. I want to note, if you don't separate, you lose all of your points. So it's important that we practice this section, okay?